Once again, we are meeting to discuss the double integrals part 3. We have already done double integrals part 1, double integrals part 2, and this is a part 3. In part 3, we mainly discuss about the change of order of integration of double integrals. I am Dr. Krishna Prasad, Professor in Mathematics, Department of H&S, MLR Institute of Technology, Hyderabad. So let us proceed now. Now, first of all, why do you contemplate change of order of integration? That is the first and fundamental question. See, the change of order of integration is sometimes inevitable because the order in which it is given may not be amenable for integration, or it is very difficult to integrate in the given order. Suppose there is a inside one is with respect to y, outside is with respect to x. You are not able to integrate in the given order, then you want to change it. Change it means now inside will be x, outside will be y. So let us see now the first point here. If the limits of the integration in double integral are constants, if the limits are constant in double integrals, then the order really does not matter. You can change it without any problem. Just like that. First one you can write down as second one you can write down as first one, and then evaluate. Now, second point. When the limits for inner integration are functions of a variable. So, we have discussed in the part 1 actually there are two types of limits. The first one is all of them are constant. Second one is variable limits. Inside is variable limits. Means they are functions of x or functions of y. Then just like that you cannot change the order. The change of order of integration will result in changes in the limits of integration. So, remember this, when it's a constant limits are there, all the four, you can change it without any problem and you can do it. But if the inner limits are variables, then just like that you cannot change, and there is a procedure for that. Now, number 3, sometimes when the order of integration is changed, the given region has to be split into 2 or 3 regions. So, actually you have to understand what is the given region, and if the order is reversed, and what is happened to that given region, and you may not be able to perform the integration as a single region. It has to be cut into multiple regions, R1, R2, R3, etc. Now, fourth point, by changing the order of integration, the evaluation of double integrals may become easier. So, that is the fourth point. So, let us see now, without any actually further explanation, let us jump into the examples. By these various examples, you will come to know actually what is the importance of this changing the order of integration. Now, here in the first example, evaluate this double integral inside x equal to y, x equal to 2 minus y. Inside is with respect to x, and outside is with respect to y. The integrand being xy. Now, the question is evaluate this by changing the order of integration. So, whenever you want to change the order of integration, first of all, see whether all of them are constant limits. No, it is not constant limits. Inside limits are variable limits. That means you have to draw the figure first of all. What is the region of integration? So, now try to understand what is the region of integration here. There are two curves here. You can see x equal to y that we have drawn. The other one is x equal to 2 minus y. X equal to 2 minus y. Now, draw. These two are straight lines. You can draw, and then they are actually cutting. This is a O. This is A, and this is a B. So, this is a region of integration, OAB. It's a triangular region. This is a region of integration. Now, he wants us to change the order. To change the order means inside is x. Inside x, it's given. And this inside x, we have to make it as inside y. Inside integration should be y. So, it is inside y means you have to take vertical strip. So, now let us take a vertical strip. Once you got the region of integration, you take a vertical strip like this. This is a vertical strip, and of course, that x-axis, this is now y equal to 0. Once you take a vertical strip, what is happening here is that actually it is moving along the x-axis. You can see At the point A, the upper line will change. From O to A, the upper line is x equal to y, but from A to B, the upper line is x equal to 2 minus y. Therefore, you have to convert into two regions, first region and second region. In the first region, y limits are y equal to 0 to y equal to x, and x limits are x equal to 0 to x equal to 1. That's what is given here. In the region 1, x is changing from 0 to 1, y is changing from 0 to x. In the second region, if you see once again, take a vertical strip, then what is the y? Y limits are y equal to 0 to y is equal to 2 minus x. Y equal to 0 to y equal to 2 minus x. And what are the x limits? X is starting from 1 and going up to 2. Because what is this point? 2 comma 0. So it's going up to 2. So in the second region, x limits are 1 to 2 and y limits are 0 to 2 minus x. So a single region for inside x limits has become two regions for inside y. So this is what you have to understand. Once you understand that, now try to write down. So this is a given one. You can see the given one is a single region. It's cut into two regions. This is the first region. This is the second region. And I already given the limits. You can see y equal to 0, y equal to 0 to x, x equal to 0 to 1, y equal to 0 to x, x equal to 0 to 1. And here y equal to 0 to 2 minus x, x equal to 1 to 2, y equal to 0 to 2 minus x, x equal to. So these two double integrals have to be separately evaluated. Now y integration is y square by 2. And here also y integration is y square by 2. And now put the limits here. In the first integral, put the limits 0 to x. And in the second one, put the limits 0 to 2 minus x. So x into x square will become x cube by 2. First integral. In second integral, actually, it becomes a bigger one because it's a 2 minus x whole square. So 2 minus x whole square, that 1 by 2 is out. Multiply by x. Then you get this 4x minus x square plus x cube. I repeat once again here, 2 minus x whole square. 2 minus x whole square, if you expand, you will get 3 terms and multiply by x, you get this. Now finally, you integrate with respect to x. That x cube integration is nothing but x raised to 4 by 4. 4x integration, 4x square by 2, 2x square. 4x square integration, 4x cube by 3. X cube integration, x raised to 4 by 4. Here put the limits x equal to 0 to 1. Here put the limits x equal to 1 to 2. Simplify, you get the answer 1 by 3. The simplification, I leave it to you. You can do it very easily. It's always, just listen first and then try to do it on your own. That's better. Okay, this is the first example on change of order. The next one is once again, evaluate this integral by changing the order of integration. Now, whenever you want to change the order, first of all, observe this inner limits. The limits are variables. If the limits are variables, then first of all, try to identify the region of integration. Once you identify the region of integration, then very easily you can change the order of integration. So now if you see carefully, from the first one, x equal to 0, x equal to y. From the outer ones, y equal to 0, y equal to infinity. So these are the 4 limits you get from the double integral. X equal to 0, x equal to y. Y equal to 0, y equal to infinity. Then this is 0, a, b. That is the region of integration. Because if you take a horizontal strip, naturally x equal to 0 to y, y equal to 0 to this will be infinity. Once you understand this is a region of integration. Now try to change it. If you change that now, what happens? You have to take a vertical strip like this. You take a vertical strip. If you take a vertical strip, then what happens? Inside will be y, outside will be x. So what is the starting? Y equal to x. And what is the top? Y equal to infinity. Left, x equal to 0. Right, this right. So this line is x equal to infinity. So once you change it, these are the limits you get. Now let us see in the next slide. So the given double integral is written as, you can see that y equal to x to infinity, y equal to x to infinity, x equal to 0 to infinity, x equal to 0 to infinity. This is x and this is y. Now, what about this integrand? For this integrand now, y e raised to minus y square by x. With respect to y, x is a constant. So let us not worry too much about that. And then this y, you can write down as 2y by 2 e raised to minus y square by x. So y square differentiation is 2y. So what is happening here is that now this y square you can integrate because 2y is already there. So you have to understand what is happening here. T is equal to y square. dt is equal to 2y dy. So this becomes actually 1 by 2 out, 2y into dy. 2y into dy will be dt e raised to minus t divided by x. But what is the t? T is equal to y square. So if you integrate this now, what you will get is e raised to minus y square by x upon, so this is integration. What is the integration you will get now? E raised to minus t by x upon minus 1 by x, because x is constant with respect to t. And now put it back. The t, what is the t? Y square by x upon minus 1 by x. So you can see this now. Okay, this you will understand this, how you got. Okay, so the integration of this with respect to y is e raised to minus y square by x upon minus 1 by x. The limits are, now you can see, y equal to x to infinity. Once you put the limits, naturally denominator by denominator becomes numerator. So the integrand become x e raised to minus x, minus into minus, that will be plus, because e raised to minus infinity is 0. Remember that. The limits are from x to infinity. But e raised to minus infinity is 0. You get minus, minus into minus will be plus. So therefore, what is the integrand that you are getting? X e raised to minus x. So this is what now you have to concentrate. X e raised to minus x dx. Now this is the integration by parts. So by you doing integration by parts, x integration, first function integration second, e raised to minus x upon minus 1 minus differentiation first, 1 integration second, e raised to minus x, and the limits are from 0 to infinity. E raised to minus infinity 0, therefore upper limit will be 0. Here there is a minus, that minus into minus will be plus, therefore it is x, that x is 0 actually. So therefore now this term will lead to 0 minus 0, and this is a minus, e raised to minus infinity minus e raised to minus 0 minus 0 minus e raised to minus 0 is 1. Only thing is that now here it is 1 by 2. If you see this 1 by 2, whole thing multiply by 1 by 2, whole thing multiply by 1 by 2, whole thing multiply by 1 by 2. So it is 1 by 2. So we have used here integration by parts. Integration by parts. Because there are two functions, x into e raised to minus x. So once again we have shown how to change the order of integration. The inside is y. You made it as inside is x. So let us take up another example. Now if you see this example now, evaluate integral inside 1. Inside is x. Outside is y. Now what is that? X is equal to under root 4 minus y, or this is nothing but x square is equal to 4 minus y, or y is equal to 4 minus x square. This is a parabola. This is a parabola, and this is what we have given already there. Y equal to 4 minus x square is a parabola. Very good. And now what is x equal to 1? So one curve is parabola and other one is x equal to 1. This is x equal to 1. Straight line, vertical line. Next, bottom. The bottom is y is equal to 0 and the top is y is equal to 3. So this is a region of integration. You can see there, this is the one. A, B and C. This is a region of integration. Now you want to change the order. If you see this inside is x, you want to make inside x. Now you want to make it as inside y. Inside y means you have to take a vertical strip. Vertical, like this. It's a vertical strip. Vertical strip. Now bottom, okay, once you take that, see this vertical strip like this. What is the bottom? Y equal to 0. So y is equal to 0 to y equal to 4 minus x square. This is a parabola. Next, x, left limit, x equal to 1. And right, this one, this point now. Okay, if you put y is equal to 0, x will be equal to 2. See carefully. Y is equal to 4 minus x square. Now put y is equal to 0. So what happens? 0 is equal to 4 minus x square and x is equal to 2, positive root. So these are the limits now. And of course inside whatever it is there, x plus y, dy, dx. Okay, now I hope you understood this. So the inside x has been converted into inside y. Once you do that, now rest is very easy because integration. Now you have to do with respect to y, x integration with respect to y, xy because x is a constant. Y integration is y square by 2. Put the limits 0 to 4 minus x square, 0 to 4 minus x square. You can see here. The limits are 0 to 4 minus x square. X, y limits 4 minus x square minus 0. Y limits 1 by 2, 4 minus x square whole square. Dx, x limits are 1 to 2. Now this 4x expand. This term expand. What is that? X into 4. 4x minus x cube plus 4 minus x square whole square. Now that a minus b whole square. A square plus b square minus 2ab. So you expand. Once you expand this and divide by 2, this is what you are going to get. Now integrate with respect to x. For example, x raised to 4 integration. X raised to 5 by 5. So integrate with respect to x and put the limits. Lower limit is x equal to 1. Upper limit is x equal to 2. And then you get finally the answer 241 by 8. So integration is very easy here. Only thing is that you have to understand the region of integration and then change the order. Inside x to inside y. That's it. Okay, now I'll just explain one more example. First of all, I want to explain about the region of integration. That's what is very important. If you see this now, for this actually you see what is this inside? Inside is a y, outside is x. So first curve, y is equal to x square by a, or x square is equal to ay, and this is a parabola. You know very well, symmetric with respect to y-axis. This is a parabola. This is a parabola. X square is equal to ay. So the first curve. Next, this is a 1. And second one. Now the second one will be y is equal to 2a minus x, or x plus y, 2a. X plus y is equal to 2a. So this one, straight line, that straight line is nothing but x plus y is equal to 2a. Parabola, straight line. And now finally x limits. X equal to 0. You know very well, it's a straight line. Equation of y-x, x equal to 0. And if you see this, if you this is nothing but x equal to a. If you solve these two ones, number 1, number 2, you solve, the point of intersection you will get, that is nothing but a comma a. That point of intersection is a comma a. So once you understand that x equal to 0, this is x equal to 0, this is x equal to 0, and this is x equal to a, and then you got a parabola, this is a parabola, and this is a straight line. So this is the region of integration. That is the region of integration. A little bit complex, but you can understand slowly. Do it once again. Draw the diagram. You will understand now. So inside is y. You have to make it as inside is x. So once you want to make it, I will draw that once again, that region. You can see that same region I will draw. So what is happening here? It's like this and like this. And now this point is a comma a. Now what you want is that inside is x. That means you have to take horizontal strip. So if you take a horizontal strip, what is this? This is x equal to 0, y-axis. So once you take like that, so now this one will go up to this horizontal strip. The right is a parabola, but here the right is a straight line. So the right hand curve changes here at this point. So this is a first region of integration. This is second region of integration. You have to cut it into two parts. So plus, two parts. So this is the region 1 and this is the region 2. Okay, now, so let us try to see how to enforce the limits. Now for this region 1, x equal to 0 to parabola. The parabola equation you have seen already, y is equal to x square by a, or x square is equal to ay, or x is equal to under root ay. Under root ay, left, right. So bottom is naturally y equal to 0. This one, y equal to 0. So y equal to 0. And the top one here, this y is equal to a. So this is the first region, whatever that integrand xy. Now second region. For the second region, once again you have to take a horizontal strip like this, and starting point once again is x equal to 0, but this time now the ending point on the right, it will be a straight line. The straight line is nothing but, you have seen already that, what is the straight line here? Y is equal to 2a minus x, or x is equal to 2a minus y. So x equal to 0, 2a minus y, and y starting will be a, and ending this point will be 0 comma 2a, 0 comma 2a. Therefore the upper limit is y equal to 2a, and same xy dx dy, dx dy. So that's how you can convert now inside y into inside x. Only thing is that a single region of integration is converted into two regions of integration, and then you have to, both of them individually, you have to find out the values. Okay, that can be done very easily. You can see that and then finish it off. That answer, by the way, the answer is given because I did not want to do that completely, and because the integration of xy is very easy, x integration x square by 2, etc., etc. So you can do it very easily and then put the limits. You get the final answer as a 3a raised to 4 by 8. So this is the fourth example we have covered about the change of order of integration. Okay. Now just I have given one more there. This is another one. Change the order of integration. Okay, you can see once again briefly. I don't want to discuss too much here because enough has been explained about how to change the order here. Inside it is y. So inside y, has to be converted into inside x. Inside y means it's a vertical strip. So here you have to take a horizontal strip. There is a difference. Okay, now so this is the region of integration. So the given one is a single region with respect to y, but if you go for with respect to x, once again it is cut into two parts, d1 and d2, two regions. So this one will become I1 plus I2. So instead of one double integral, you have to go for two double integrals. And then, by the way, yes, you can take it as a homework and then complete that. And I have given enough hints here how to change it. Okay, the answer is also given here, by the way, so that you can verify your answer once you have given the limits. I1, I2, the limits are given, and of course integrate and then put the limits, you will get that answer. Okay, with that we come to the end of change of order of integration. This is a part 3, and then we'll meet once again in the next part and we'll discuss about the triple integrals. Till then, thank you and goodbye.